Hi Telangana students, how are you all of you? Right, Andy, I think you are enjoying my videos excellently. Nice comments also you are putting. Very good, we have successfully completed 5 units or 5 chapters. Now let us enter into the 6th unit or 6th chapter, very important, Andy. And that is nothing but system of particles and rotational motion. Start chedam mari. So Telangana students, please open your new textbook, Andy. Unit 6. Unit 6, okay na? That is system of particles and a rotational motion. So this is our new topic, and okay na? So start chedam Telangana students. Are you ready? Take your notebook and your new textbook in front of you. Start the concept. Unit 6 and this is the 6th chapter for our new syllabus, Telangana students. System of particles and rotational motion. Now let us see what we will be studying in this concept. First of all, let us complete all the 3 videos of the concept. Then 2 marks, 4 marks, 8 marks, and also we will go to the textbook problems. Okay na? So mundu concept anta complete chedam. See, in previous chapters we have studied about the particle nature, that is unit mass, movement along a straight line, 2 dimensional, etc., etc. Now in this chapter we will be studying about system of particles. That means the whole body. In that so many particles will be there. If you take a big body, okay, inside so many particles will be there. So when the body is moving, either in translation motion or rotatory motion, how the particles are moving inside that body? Are they moving in the same direction or in different directions? So in all these things will be studied in the system of particles. So దీన్నే మనం సింపుల్గా చెప్పాలంటే ఇంకో మాటలో సెంటర్ ఆఫ్ మాస్ అని కూడా చెప్పొచ్చు. సెంటర్ ఆఫ్ మాస్, ఓకేనా? సో ఇవన్నీ కూడా ఈ డీటెయిల్స్ మనం ఈ చాప్టర్లో చదువుదాం, ఓకేనా? సో లెట్ us see అండి. See, we all know regarding translatory motion. In different types of motion law, we all know what is translatory. Okay na? Now what is translatory? Translatory ante linear motion. Tarvata inko point ante, in this motion, if you observe carefully, every particle in that body will experience same velocity and acceleration. For example, a body is sliding down on inclined plane, smooth inclined plane, okay na? This inclined plane ABC, smooth inclined plane, smooth inclined plane surface. Now when it is sliding down, you can see every particle in that will have same velocity inside that every particle, because it is made up of fixed atoms inside, tightly bound inside the body. So every particle is moving with the same velocity, okay? So P1, P2, P1, P2, P3 particles, all will have same P1, P2, P3 inside that body, all will have same velocity, okay na? And acceleration also will be same. In the same way, suppose if a train is going, bogies are attached to the train. If the first bogie is going with same velocity, second bogie also with the same, last bogie also will be having same velocity and acceleration. So that is, you can take it as translatory motion. That means every particle will experience same velocity and acceleration throughout the motion, and the path is parallel. To the direction of motion. So this is translatory. Adotunda? Rotatory vachappudu emavuthundi with reference to an axis. That means, for example, if a top is rotating, fan is rotating, an iron bar rotating. So all these will rotate with reference to some axis. That means it may be circulatory or may not be circulatory. If the radius is constant during the rotation, that is circulatory. If the radius is changing, then it may not be circulatory. Okay, it may be elliptical. in different types of geometry. Adotna. So if you are maintaining constant radius, then it is circulatory. With reference to an axis, that is rotatory. Adotna. So those are the difference between this translatory and rotatory motion. So when any body is revolving in particular with reference to an axis, then it is called as a rotatory motion. If radius is constant, then it is circulatory. Circle eppudu avutundi? Throughout the radius is constant. If it is varying, then it is not a circle. If it is a different geometric figure, like ellipse. If any body is revolving with reference to any axis, that is called a rotatory motion. Circulatory and special case, if radius is constant, that is circulatory. Adotna Telangana students are following. First, carefully, Miru Subranga concept nechkondi. Then you can understand the remaining subject. Clear? Next one. In the same way, suppose if you take a roller in the same plane, a sphere rolling, for example, not slipping, rolling without slipping, and please make a note. Okay? No slipping, only rolling. And for example, a sphere is there, center point, touching point, this center point. You can take some more points over here. And this is another point. Okay, let's see, it is rolling. Okay, it is rolling. Rolling without slipping. Rolling without slipping. Slipping at the jarno. Roll out, jarno. Roll out, jarno. So no slipping. That one you can study later on. Okay? Rolling, slipping. Only rolling is slipping led. Jarno led. So when it is rolling, you can see the velocity are changing. Your different points you can say P1, P2, P3, P4. This is center of mass, center point. So here you are having different points in that rolling action. So when it is rolling, the velocity is changing regularly, you can see. Okay, na? Without slipping. So it has a different velocities, P1, P2, P3 as shown. Okay, na? At any instant of time. At any instant of time, you can see that velocity is not constant. As in the case of a body sliding on an inclined plane. Compared to the sphere, the velocity is changing. Okay, na? So make a note, and these are the differences. And in the same way, coming back to rotatory, as just now I told you, when a fan is revolving, it is revolving with reference to an axis. A top. When a top is revolving, okay, this is the top. When it is rotating, this is the reference axis. Okay, when iron bar is revolving or rotating about an axis or about an end, okay, you can take anything. A disc revolving, ఇవన్నీ కూడా మనం ఇందులో చదువుతాయి. About an axis passing center or about diameter or about one end, different geometrical figures when they are rotating with reference to some axis, that is a rotatory. Circulatory means special case, and if the radius is throughout constant, then it is only circle. Radius change అయిపోతే ఏమవుతుంది? It is not a circle, like an ellipse or any irregular geometrical figure. అర్థమవుతుందా? So rotatory motion means when any body is revolving with reference to a fixed axis, and that is rotatory motion. Clear? Right. Now let us see what is meant by center of mass definition. Okay, how we will define and how to calculate the center of mass on x-axis, y-axis, xy plane, three-dimensionally. ఇవన్నీ one by one మనం ఇప్పుడు చూద్దాం. Clear? Any doubts అండి? Right అండి. Now let us see what is center of mass. ద్రవ్యరాశి కేంద్రం. Center of, this is the first video అండి regarding concept, unit 6. Regarding full concepts, unit 6, that is system of particles and rotational motion. First concept and first video. So what is center of mass? ద్రవ్యరాశి కేంద్రం అంటే ఏంటి? First of all, let us understand the concept. Suppose if we take different bodies like rectangle, square, sphere, that is solid sphere, hollow circle, లేదా హాలో రింగ్ అండి, హాలో రింగ్ తీసుకుందాం. ఇది హాలో రింగ్, ఇది సాలిడ్ స్పియర్, స్క్వేర్ and rectangle, and last one triangle, irregular triangle, taking small pieces, because for this triangle what is centroid? Altitude, you can see the medians meeting. Medians with the center point, you can see this is median dividing into two sides. So this is the centroid here, okay, for a triangle, medians. In the ratio of 2:1, this is centroid or center of gravity. In maths, you will be saying a centroid, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Maths lo aithe centroid anna x1 plus x2 x3 by 3 coordinates, leda y1 plus y2 plus y3 by 3. This is also called as center of gravity. That means a fixed point inside the body from where the force is always pulled downwards. That is CG. Center of mass ante the total mass of a body is supposed to be concentrated. That is called center of mass. It varies from body to body. You can see for rectangle, this is the center of mass. From here the weight is pulled downwards. In the same way for square also at the center, solid sphere also center. Now hollow ring, inside no mass is there, so it will be somewhere outside. Center of mass will be outside certain, because inside no surface mass is there. And triangle, the medians meeting at a point, median and end separating two equal parts, triangle. So this is the centroid, x1 plus x2 plus x3 by 3, y1 plus y2 by y3 by 3, and that is also called as center of gravity. The resultant force always pointed downwards, okay, from a fixed point inside the body. That is called as center of gravity. Mathematics lo then centroid antam, physics lo center of gravity. Centroid means that you can see the medians meeting at a point. Chudandi, triangle lo idoka median separating into two parts, idoka median meeting at that point at G. Okay, not altitude. Altitude ante perpendicular. Median ante separating into two equal parts. Chudandi, this is separating into two equal parts, same equal parts. Okay na? So like this you can separate the center of mass ante. So the total mass, what is mass? Total amount of matter contained in a body is called mass. What is matter? Atoms and molecules. See, you can see this is a matter, sketch pen. Camera is a matter, myself is a matter made up of atoms and molecules. So any object having some mass occupies some space. That is a matter. So where the total mass of a body is supposed to be concentrated, that is called as center of mass. Supposed. ఎక్కడైతే మనం అనుకుంటున్నామో, depending upon the structure of the body, depending upon the geometry of the body, center of mass changes. So simple definition ఏంటంటే the total mass of the body where it is supposed to be concentrated, that is called as center of mass. దాన్ని ద్రవ్యరాశి కేంద్రం. It varies from body to body. Clear? For a triangle it is called as centroid అండి. The medians meeting at a point, all the medians, that is a centroid. x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, the coordinates. Later physics literature it is called as center of gravity. Now some more examples we will deal about center of mass. Regarding center of mass, we will see some more examples. Suppose when you throw a badminton bat, you can observe carefully. This is the badminton bat. Okay, this is the badminton bat. You can see when the body is thrown vertically upwards, badminton bat or an axe, badminton bat or an axe, gotali. So you can see it is going in a different fashion, but there is a fixed point in it. There is a fixed point in it, which makes the path a parabolic. Which makes the path parabolic. That fixed point is called as center of mass. అదేవిధంగా సైకిల్ చూడండి, మనం స్టార్ట్ చేసే ముందు కొంచెం ఇటు అటు అవుతుంది when you are pedaling the cycle, but after some time it goes in a linear motion. That point where the pedal makes a straight, that is center of mass. Or you can see, for example, now see this book, see this notes. Now it is a rectangle shape. Now if you want to balance this one, what I have to do? Even though I don't know physics, because it's a rectangle, I can just put at the center my fingers. You can see. So why it is balancing this book? Because it is a rectangle, the total mass is supposed to be connected at the center. You can see at the center. Now you can play with the book also like this. You can play also. So why I am playing like this? Because the center of mass is located at the point, center point. That is what center of mass. So the point where it is supposed to be concentrated, that is called as center of mass of a body. Okay? Clear? These are some best examples. When a badminton bat is thrown, okay, not only that, when a cricket ball is making spin bowling, when a cricket ball is making spin bowling, you can see the trajectory. You can see the trajectory. You can see the trajectory of the ball when it is spin bowling. Parabolic in nature, you can see. There is a fixed point. It is making the ball in a parabolic nature, paravaliyalo, in a spin bowling. So all these are examples for center of mass, Dravirasa Kendram. Clear? Right. So every particle may be in complicated motion, but there is one fixed point which makes the path parabolic. When you are throwing, every particle is in complicated motion. కానీ అక్కడ ఒక పాయింట్ ఉంటుంది, దట్ ఈస్ మేకింగ్ ఏ పారాబాలిక్. దట్ పాయింట్ ఈస్ కాల్డ్ as సెంటర్ ఆఫ్ మాస్. అర్థమవుతుంది కదా? సో దిస్ ఈస్ ద ఎగ్జాక్ట్ డెఫినేషన్ ఆఫ్ సెంటర్ ఆఫ్ మాస్ అండి. ద పాయింట్ వేర్ ద టోటల్ మాస్ ఆఫ్ ద బాడీ ఈజ్ సపోజ్ టు బి కాన్సన్ట్రేటెడ్, దట్ పాయింట్ ఈస్ కాల్డ్ as సెంటర్ ఆఫ్ మాస్. ఇట్ varies from body to body. In triangle it is at the centroid, the medians meeting at a point. Hollow ring outside. Solid bodies like sphere at the center, like rectangle, square and other things. Irregular bodies you can find out by using small pieces. Okay, small pieces, elemental length, you can find out the center of mass. Now let us find the coordinates of center of mass. How to get the coordinates? Next item, coordinates of center of mass. Coordinates of center of mass. That means suppose the body is lying in which plane? Is it on x-axis? Is it on y-axis? Or xy plane? Or in space? So depending upon that you will get coordinates. For example, చూడండి నేను డ్రా చేస్తున్నాను. For example, say this is x-axis, okay, and this is y-axis. Suppose this is origin, of course, origin. Now let the bodies are on x-axis, for example, first body, second body, third body, fourth body, n bodies. Let their masses be m1, m2, m3, m4, mn, and while locating you have to say the distance where it is x1, x2, x3, and last one is xn. Now can you tell me what is the y coordinate of this body? 0, because it is lying on x-axis. So what is the coordinates? Then coordinates ఏమవుతుంది? x1, 0, x2, 0, x3, 0, last one ఏమో xn, 0. Any body which is lying on x-axis, it has only x coordinate. If it is lying on y-axis, దెన్ ఇట్ ఓన్లీ వై కోఆర్డినేట్. చూడండి, సపోజ్ ఇలా తీసుకున్నాను, ఇప్పుడు వై యాక్సిస్లో ఉన్నాయి, అప్పుడు దీనికి కేవలం వై కోఆర్డినేట్ మాత్రం ఉంటుంది. ఎక్స్ కోఆర్డినేట్ 0 అకార్డింగ్ టు మ్యాథ్స్. y1, y2, y3 and yn. So if the body is lying on x-axis ఉన్నప్పుడు ఓన్లీ x కోఆర్డినేట్ చూడండి, అంటే అప్పుడు సెంటర్ ఆఫ్ మాస్ ఎంత అవుతుంది? x centimeters or x meters given by m1 x1 plus m2 x2 plus m3 x3 plus dot 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 mn xn by capital M, where capital M is called as the total mass of the system, entire bodies, total bodies, m1 m2 m3 m4 so on mn. అది m1 x1 first body with reference to axis. ఇప్పుడు చెప్పండి, reference axis చెప్పాలి. It is on x axis, y coordinate is 0, so you don't have y coordinate, only x coordinate. సో దీన్ని మనం x axis గా చెప్పుకోవచ్చు, సెంటర్ ఆఫ్ మాస్ ఒకటే ఉంటుంది కోఆర్డినేట్. అండ్ దిస్ వన్ కెన్ రిటర్న్ యాజ్ సిగ్మా I running from 1 to n mi xi by capital M. So this is for x axis. In the same way y coordinate మీద ఉన్నాయి, y axis మీద ఉన్నాయి, అప్పుడు only you have y centimeters. Then you have sigma I running from 1 to n mi yi by capital M. Suppose it is only on the z axis, then only ఒక కోఆర్డినేట్ ఉంటుంది, zcm sigma I running from 1 to n mi zi by capital M. Are you following? If the bodies are only on x axis, if only on x axis, only you have only one coordinate. Only on y axis, only on y axis, only y coordinate, x coordinate 0. Only on z axis ఉంటే z coordinate, xy ఉండదు అనమాట. అర్థమవుతుంది మీకు? సో ఇఫ్ ద బాడీస్ ఆర్ లయింగ్ ఓన్లీ ఆన్ x యాక్సిస్, ఓన్లీ x కోఆర్డినేట్ ఉంటుంది, y యాక్సిస్ ఉన్నప్పుడు y కోఆర్డినేట్, z యాక్సిస్ z. అలా కాకుండా ఇప్పుడు సపోజ్ ఇఫ్ ఇట్ ఈస్ లయింగ్ ఇన్ xy ప్లేన్, అప్పుడు ఏంటి పరిస్థితి? నెక్స్ట్ వన్ అదేనండి, సెకండ్ వన్, హౌ టు గెట్ ద కోఆర్డినేట్స్. నోట్ చేస్తారు, ఇది ఓన్లీ ఆన్ x యాక్సిస్, ఓన్లీ ఆన్ y యాక్సిస్, ఓన్లీ ఆన్ z యాక్సిస్, అండ్ m ఈజ్ ఆఫ్ కోర్స్ టోటల్ మాస్ ఆఫ్ ద బాడీ. సరిపేస్తున్నానండి, రైట్ అండ్ ఎక్సలెంట్. నౌ సపోజ్ సెకండ్ పార్ట్ అండి, ఇఫ్ ద బాడీస్ ఆర్ లయింగ్ ఇన్ xy ప్లేన్ 2 dimensionally, ఓకేనా? ఇఫ్ ద బాడీస్ ఆర్ లయింగ్ ఇన్ xy ప్లేన్, అప్పుడు పరిస్థితి ఏంటి రాస్తున్నాను ఇక్కడండి. ఇఫ్ ద బాడీస్ ఆర్ ఆన్ xy ప్లేన్, ఓకేనా? ఐఎమ్ డ్రాయింగ్ ద ఫిగర్ వన్స్ అగైన్ ఫర్ యూ. చూడండి, డ్రా ద ఫిగర్ నీట్లీ తెలంగాణ స్టూడెంట్స్. ఇదిగోండి x యాక్సిస్, x డాష్, y డాష్, ఆరిజిన్. నౌ యూ కెన్ సీ ద బాడీ ఈజ్ ఇన్ xy ప్లేన్, అంటే ఇక్కడ ఉంది m1, అలాగే m2, m3, mn. So it will be having coordinates x1 y1, x2 y2, x3 y3, xn yn. So what are these coordinates? ఇక్కడ రాస్తున్నాను, x1 y1, x2 y2, x3 y3, and final one xn yn. So when the bodies are lying in xy plane 2 dimensionally, coordinates of రెండు ఉంటాయి, center of mass. So what is the center of mass again? X centimeters. Again, m1 x1 plus m2 x2 plus m3 x3 dot 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 mn xn by capital M. Capital M is the total mass of the body. This is x coordinate. అలాగే y coordinate, ycm m1 y1 plus m2 y2 plus m3 y3 plus dot 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 mn yn by capital M. Are you following, all of you? తెలంగాణ అర్థమవుతుంది మీకు? Let me check my mic, it is working. Yes, my mic is working. So these are the coordinates of the center of mass of n bodies lying in xy plane. Then one mathematically you can write in this fashion: xcm again it is 1 by capital M total mass sigma I running from 1 to n mi xi x. అలాగే ycm 1 by capital M sigma I running from 1 to n mi y xi mi y. Substitute the value 1 m1 y1, 2 m2 y2, 3, and what is this m total mass? And please, capital M is m1 plus m2 plus m3 plus dot 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 mn, total mass of the body, total mass of the body system, మొత్తం సిస్టమ్ అంత మాస్ అంతా కలిపి సిస్టమ్. ఇది xy ప్లేన్ నోట్ చేసుకోండి. లెట్ us go to the 3 dimensional. నెక్స్ట్ వన్ ఇంకేం లేదండి, స్పేస్ ఇంకోటి తీసుకుంటాం మనం, జెడ్ యాక్సిస్ వస్తుంది అంతే. నోట్ చేశారా? రైట్. నెక్స్ట్ థర్డ్ కేస్ అండి. థర్డ్ కేస్, ఇఫ్ ద బాడీస్ ఆర్ లయింగ్ ఇన్ స్పేస్, సెంటర్ ఆఫ్ మాస్, clear? Right. And now if the bodies are lying in space, if the bodies are lying in space, that is 3 dimensionally, అప్పుడు 3 ఉంటాయి చూడండి, ఎక్స్ వై జెడ్ అనమాట. అంటే ఎలా ఉన్నాయి ఇప్పుడు, ఇదిగోండి ఎక్స్ వై z axis. Suppose bodies are distributed in this fashion in space, 3 dimensional ఉన్నాయండి, m1 m2 m3 m4 m5 m6 m7 m1 m2 m3 m4 m5 m6 mn. So what is the coordinates? x1 y1 z1, x2 y2 z2, అదవుతుందా, x3 y3 z3, x3 y3 z3, అలాగే xn yn zn. అంటే 3 కోఆర్డినేట్స్ ఉంటాయి స్పేస్లో. అప్పుడు ఏముంది, ఇందాక చెప్పినట్టుగా ఉండి ఎక్స్ట్రా పార్ట్ ఒకటి ఎస్ ఉంది. ఎక్స్ట్రా పార్ట్ ఏంటది, ఎక్స్ కోఆర్డినేట్ ఉంటుంది, సిగ్మా ఐ రన్నింగ్ ఫ్రమ్ 1 to n mi xi by capital M. అలాగే y కోఆర్డినేటర్ సిగ్మా మీన్స్ సమ్మేషన్, యాడింగ్ ఆఫ్ ఆల్ దోస్, m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus mn xn అని యాడ్ చేయాలండి ప్లీజ్. I running from 1 to n mi xi, that is mi yi by capital M. అంటే m1 y1 1 పెడితే, m2 y2 2 పెడితే, m3 y3, అలాగే mn yn. అలాగే లాస్ట్ z యాక్సిస్, sigma I running from 1 to n mi zi by capital M. And of course capital M, total mass of the system m1 plus m2 plus m3 plus dot 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 mn. అదవుతుందా? So when you put 1 you will get first one, 2, second one. So like that, x coordinate, y coordinate and z coordinate, mi xi, mi yi, mi zi. So this is in space and when bodies are distributed in space, in this way you will be getting. Clear? Clear అండి? Any doubt? అలాగే వెక్టార్ ఫామ్ కావాలంటే xi yi z అనమాట. ఓకేనా? అలా కూడా రాసుకోవచ్చు. ఓకే, ఇఫ్ యూ వాంట్ ఇట్ ఇన్ వెక్టార్ ఫామ్, యూనిట్ వెక్టార్ ఫామ్, xi into i cap, yi into z cap. Okay, like that also you can get it. Vector form, if you want it in vector form. If you want it vector form, r bar xi, that is x coordinate, xi yi, okay na, x y and z direction and if you want the position vector and r, okay na, so that also you can calculate in that fashion. Ri, xi into I cap, that is yi into j cap, zi into k cap. Okay na? That is xy, xi, yj, z cap. So in terms ala kuda raskochu. In terms of position vector, xi into I cap, yi into j cap, zi into k cap. In form of vector form. Along x direction, y direction, z direction, position vectors. Adoutunda meeku clear? Any doubts? Okay. సో ఇదండి మనకి రిగార్డింగ్ 3 డైమెన్షనల్లీ. అలాగే ఎప్పుడైనా కంటిన్యూస్ మాస్ డిస్ట్రిబ్యూషన్ వచ్చింది అనుకోండి, అప్పుడు ఇది పనిచేయదు మీకు. ఎందుకంటే మనం పాయింట్ మాసెస్ అయితే వాడుకోవచ్చు. పాయింట్ మాస్ అంటే చూడండి, ఫర్ ఎగ్జాంపుల్ suppose if you want to find out for continuous mass distribution, then you can't apply this one m1 x1. అర్థమవుతుందా? You can only apply for these bodies. చూడండి, these bodies you can apply. ఇది one m1 m2, you can find the center of mass somewhere over here because it's a point mass. Point mass. Suppose if it is an iron rod లో ఏముంటాయి? చిన్న చిన్న ముక్కలు ఉంటాయి. You can see small pieces of rectangle. So if you add up all these pieces, only then it becomes the total length. So the mass is distributed fully. But you cannot apply m1 x1 plus m2 x2. Then you have to go by integration method. Then the x coordinate is given by integral x dm by capital M, where m is the total mass. Total mass of the body. M is the total mass of the body. X coordinate, అలాగే y coordinate, integral y dm by capital M, అలాగే z integral z dm by capital M. This is for continuous mass distribution. Point mass కి అప్లై చేస్తాం. m1 x1 plus m2 x2 plus m3. సో ఇక్కడ ఆ ఫార్ములా ఇక్కడ చెల్లదు. You cannot apply the point mass formula here. m1 x1 plus m2 x2 plus m3 x3. అది మనం పాయింట్ మాస్ అని ఊహించుకున్నాం పార్టికల్ని, అంటే ఆ బాడీని సింగిల్ పాయింట్. అందుకే మనం m1 x1 పెట్టేసాం. ఒక చిన్న డైమెన్షన్, అంటే దాని సైజ్ మనకి చాలా చిన్నదని అర్థం. పాయింట్ మాస్ అంటే అర్థం ఏంటి? యూ కెనాట్ మెజర్ ఇట్, వెరీ స్మాల్ ఇన్ సైజ్. బట్ వెన్ యూ టేక్ ఎ బిగ్గర్ వన్ లైక్ అన్ ఐరన్ రాడ్, హౌ కెన్ యూ అప్లై m1 x1 plus m2 x2? Then you have to go by integration. Integral x dm by capital M. M is the total mass. This is the x coordinate. Integral y dm by capital M, total mass, y coordinate. Integral z dm by capital M, z coordinate. So like this you will get the coordinates and for continuous mass distribution. ఇక్కడ రాస్తున్నాను. This is for continuous mass distribution like this iron rod. You can't apply m1 x1 directly, then you will go wrong. Because this iron rod made up of small elemental lengths. So అందులో చిన్న మొక్క తీసుకొని you'll find out by integration to get x coordinate, y coordinate, z. అందుకే ఫార్ములా ఇచ్చారు. Integral x dm by capital M total mass, integral y dm by capital M, integral z dm by capital M. So point masses మనం అప్లై చేసేవచ్చు. m1 x1 plus m2 x2 by m1 plus m2 m3 so on and so forth. For continuous mass distribution you cannot apply that formula, you have to go by integration method. Okay na? So this is and up to here. I'll end up the video here. In next part we'll be dealing about what is difference between center of mass and center of gravity. Tarvata some properties of center of mass, and also what happens to the velocity of center of mass, acceleration of center of mass when the body is moving. Okay, and in during explosion, bomb explosion, what happens to the fragments when the center of mass changes. అదొకటి. నెక్స్ట్ తర్వాత different types of theorems and parallax theorem, perpendicular theorem, moment of inertia of different bodies, and తర్వాత లాస్ట్ లోని rotational motion and equations, kinematic equation, rotational motion. ఇవన్నీ కూడా నెక్స్ట్ కమింగ్ వీడియోస్లో, బికాజ్ ఐ టోల్డ్ యూ in 3 videos I'll be completing concept, and next 2 marks, next 4 marks, hardly 7 videos are coming for every chapter hereafter. మూడేమో వీడియోస్ కాన్సెప్ట్, ఫుల్ కాన్సెప్ట్ ఇన్ దట్స్ అకార్డింగ్ టు న్యూ సిలబస్ తెలంగాణ. తర్వాత 2 marks కంప్లీట్ టెక్స్ట్ బుక్ 2 marks, అలాగే కంప్లీట్ టెక్స్ట్ బుక్ 4 marks క్వశ్చన్స్, డెరివేషన్స్, ఎక్స్ప్లెయిన్, అలాగే కంప్లీట్ లాంగ్ ఆన్సర్స్, LAQs, డెరివేషన్స్. తర్వాత న్యూమరికల్స్ అండి, ఆల్ టెక్స్ట్ బుక్. ఇవన్నీ మనం కవరేజ్ ఈ విధంగా చేస్తాం. ఓకేనా? సో ఐ బిలీవ్ దట్ యూఆర్ ఫాలోయింగ్ మై ఛానల్ అండి. సబ్జెక్ట్ కూడా బాగా అర్థమవుతుందని తెలిసింది. అగైన్ ఐల్ బి మీటింగ్ ఇన్ ద నెక్స్ట్ పార్ట్ ఆఫ్ ద వీడియో.